They are saying find the least value of n such that when we multiply the two complex numbers z1 and z2, that should be r plus. What does r plus even mean? R is a real number and plus is of course positive. So what they mean is when you multiply the two complex numbers, the end result should be a real number. But remember, we are dealing with the cis functions, which is having an imaginary part. Remember, the cis theta is cos theta plus I sine theta. Now, cos theta is the real part, sine theta is the imaginary part. If we want our complex number to be only real, that means the imaginary part needs to be zero. So take that as a concept. Whenever it's given, any complex number is real. That would mean the complex part of that particular complex number is zero. A small little mistake which a lot of students do is remember the imaginary part is only sine theta. It is not I sine theta. So real part is cos theta, imaginary part is sine theta, and that needs to be zero for the complex number to be real. So let's do that. Now let's multiply Z1 and Z2 using the property of cis. Z1 into Z2 will be equal to, first we multiply the two magnitudes together. 3 into 2 will become 6, 6. And then the two cis functions, let's multiply them together. N pi divided by 16. Now we know the property of cis when they are multiplied. Let's go back to the property. Here it is. So when the two cis functions are getting multiplied, in the result, your arguments are adding up, right? So we use that. So it'll become 6 times cis 3 pi by 4 plus n pi by 16. Now, according to the question, this is a positive real number. It's a positive real number, right? Now, as we saw, for the complex number to be real, its imaginary part needs to be zero. So just for explanation, let us expand the cis parameter. So cis, remember, is cos theta plus I sine theta. So it will be cos 3 pi by 4 plus n pi by 16 plus the I sine of 3 pi by 4 plus n pi by 16. But remember, 6 was originally the modulus. So 6 will be multiplied with both parameters, both the cos and the sine parameters. So we'll get 6 times sine of the entire bracket. So now let me just carefully tell you that this entire parameter, which is in front of the I, this is your imaginary part. Now, for the complex number to be real, the imaginary part needs to be equal to 0. So let us write. So the sine function 3 pi by 4 plus n pi by 16, this will be equal to 0. Now, see, this can be either you can solve manually or we can use the calculator for this. Now, let's use the calculator. So if you take the calculator and put the sine value, the entire function, and put that equal to 0. So we will get different values of n. The values of n which we will get is n is equal to 4, 20, 32, and so on. Now let's go back to the question. We were supposed to find the least value of n such that the product z1, z2 should be a positive real number. For that, we made sure that the imaginary part is 0. Hence, we got that list of numbers. Now, since the product has to be positive, we need to make sure that the real part of this complex number, which is cos, this needs to be positive. Now, since we are supposed to find the least value of n, technically 4 should be the answer, given the real part should be positive. So let's try to find out if that is the case. So what we will do, we will put n is equal to 4 in place of this entire bracket. So let's see what do we get. So 6 times cos of 3 pi by 4 plus, now we put n is equal to 4 here. So 4 pi by 16, which will simplify to pi by 4. And if you further simplify this, we will get 6 times cos pi. Cos pi is -1. So eventually we will get -6, which is clearly a negative number. Hence, the value of n is equal to 4 cannot be the right answer. We have to discard that. Let's repeat, why are we discarding that? because on putting n is equal to 4 in the real part, that is coming out as negative, which was violating the given condition that the product has to be positive real number. So n is equal to 4 is definitely out. Now let us check at n is equal to 20. Does the real part becomes positive? So let's write that down. So the real part of z will become 6 times cos of 3 pi by 4 plus. Now we are putting n is equal to 20 over here. So 20 pi by 16 simplifies to 5 pi by 4. And if we simplify this, we get 6 times cos 2 pi. And since the value of cos 2 pi is positive 1, we get plus 6 as the eventual answer, which clearly is positive. Hence, n is equal to 20 is indeed that minimum value of n at which the multiplication of z1 and z2 is a positive real number. So 20 is our answer. And that's how we solve this question. There are two complex numbers presented here, z and w, and the part A is to find the product, z into w. So let's do that. So multiplication, we will use straightforward multiplication trick. So multiplying the two brackets together. So let us open up these brackets. 2 times 1 minus 2i plus I times 1 minus 2i. And let's simplify this to get 2 minus 4i plus I minus 2i squared. And remember the value of I square is negative 1. So minus 2i square will become positive 2. So let's write that down. So we'll get 2 minus 3i in the middle and we have a plus 2. So eventually the ZW product comes out as 4 minus 3i. And that is the answer for the first part of the question. In the B part, we have to plot the three complex numbers Z, W, and ZW on the same Argand diagram. So Z and W are already given and ZW we just found out. So the Argand diagram will look like this. So observe Z was 2 plus I, which means Z is 2 units in the real axis and 1 unit in the imaginary axis. Similarly, W was 1 minus 2i, which means W will be 1 unit in the real axis and 2 units negative in the imaginary axis. Similarly, for ZW, it is having 4 minus 3i as the complex number. So 4 units in the real axis and negative 3 in the imaginary axis. Part C. We have to find the angle theta between ZW and W. So first of all, let me label that area or rather the angle. So this particular angle is what we have to find for part C. So how do we do that? So we will use the concept of argument. Remember, what does argument even mean? Argument is the angle which the complex number makes with the positive real axis. So what we will do, again, we'll use the calculator to figure out the argument of ZW first. So if we use the calculator and figure out the argument of ZW, understand the concept, the argument, either you can use the calculator directly, it has a function, or we do tan inverse of the imaginary coordinate divided by the real coordinate. So minus 3 divided by 4. And if we simplify this, the argument comes out as minus 0.643 approximately. Let's show that in the diagram. So we'll go from the real axis and towards ZW. So this particular angle is negative 0.463. See, the significance of minus is only that the angle being measured is clockwise. Otherwise, we take positive as anti-clockwise. So this is your angle 0.463 in the clockwise direction. Now, similarly, we have W, which is 1 minus 2i. And using the same logic, and let's use the calculator to get the argument of W. So argument of W can be found using the tan inverse function, imaginary coordinate divided by the real coordinate. So minus 2 upon 1. See, W is 1 minus 2i. So minus 2 is the imaginary coordinate, 1 is the real coordinate. So either we do that or there is a direct function in the calculator to figure out the argument. So that in that case, argument will be negative 1.107 approximately. Let's plot that as well. So starting from the real axis, if we go towards W, So watch carefully this green angle which I have made. This is the angle which we have just found out. Negative 1 point minus 1.107. Now, in any case, let me just zoom this out for you to understand very carefully. So what we have found are two angles. First is the argument of ZW, and then we have found the argument of W. The angle which we need to find is this. To find that angle theta, observe how do we do that. So we have a bigger angle. If you subtract the smaller angle from this bigger angle, we will get theta. So theta will be equal to argument of W. Remember, argument of W which we found was negative minus 1.107. So just to make the calculations easier, we will take the magnitude only. So argument of W, but the positive with a positive sign. And we subtract the argument of ZW from it, again taking the modular sign. So argument of W was minus 1.107. So if we take the modulus of that, we get 1.107 minus argument of ZW, only the value itself, 0.463. So minus 0.463. And if we subtract these two values, we will get approximately 0.464 radians. That's how we find the angle theta.